Hi everyone, welcome to another video on that's going to cover the basics of the random walk stochastic simulation, the very introductory concept one should understand before entering into more advanced stochastic discrete processes, even continuous stochastic processes. And so today I'll go through a basic random walk using the values -1 and 1. So over time, if we track the cumulative sum of of all of the previous processes, then we will be able to graph things randomly based on this kind of random walk idea. And it's actually really simple to implement in Jupyter Notebooks and Python. All we need is the random library and the matplotlib.pyplot library. So we'll go ahead and import those, move on to the next one, and we're going to start defining our function, random walk. And I have two inputs. One is going to be this list of choices that we are going to randomly choose in our function. That'll be one input. And then the other input will be our time, or our max time, the time we want to simulate up to. Okay, so to do this, the first thing we want to do is store our time steps as we go along. And the other thing we want to do is store our cumulative sum as we go along, or the sum, yeah, our cumulative sum as we go along. Now, one thing we want to do is we want to start from the origin. And so we're going to go ahead and say our first time step is going to be, we're going to start at 0, and our initial x value, or initial sum, will be 0, so that we can just start from the origin and track it without jumping to the first coin flip at time 0. But time 0 we're going to find as having a 0 value, so we can begin it from the origin. And it's going to be a fairly simple loop. And so if I just go for time step in the range of 1 to time, range from 1 to time, what time this is going to be is our time step starting from 1, 2, 3, all the way up to the max time. Now the thing with range, right, is we go start value before the comma to the end value -1, and so we're just going to add a 1 here. Okay, so for TS in range of 1 to time plus 1, we're going to go TS dot append the time step so that we can save the time step. Then we're going to define our random choice, which is just as simple as going random dot choice of the values in our input list. Now we can define our step. And so our step is just going to be the value of the previous element of our list plus the random variable we just chose from our input list. Now, when it comes to choosing the indexed value from the previous list, it actually lines up perfectly with our TS value, except it's not quite perfect. We have to subtract 1. So our TS -1, and so TS, for example, on our first round of this loop is going to be 1, and so x of 1 minus 1 equals x of 0, and the 0th element of the x list is going to be 0. And so this is going to be 0 in our first loop plus our random choice. And so that's the idea there. Usually if it got more complicated or the index didn't line up easily with our output function or output list, or the list we want to draw from when we say plot something, I'll use the enumeration of this range. But since this lines up pretty well, we don't have to do that. And then we'll go ahead and store it in our x value. So x dot append our step. And it's as simple as that. And so it'll go through those time steps until we hit our max time. And then at the end of everything, we just want to plot everything. Okay, I think that's going to do it. And so if we have, say, if we define a random walk of some list, let's give the values -1 and 1 time, and this could be, or time equals We could just say 50 here, actually. So we'll do 50 steps from 0, which is going to start from our origin based on what we defined, all the way up to time 50. And of course, well, PLT is not defined. What do I do now? Fig size. Oh yeah, I guess I'm just... And so that's going to be our random walk. And so it looks like this was, more favorable, or we randomly chose the positive one more than the negative one. Whereas if I run this again, it'll be more favorable. It looks like it went negative more often. If I run it again, right, this is just random walks based on our input list. And so basically, when it comes to more advanced stochastic processes, we're going to take some random time interval, or really small interval of time, and calculate the probability of one reaction, or of the reaction running, that is a specific reaction running at that time. And so if I go ahead, it's the same idea as like, okay, I choose -1 to be added to my cumulative sum versus 1 being added. But if I could also just be like, okay, I have the random step of choosing 10 as my as another option, say another reaction. If we run that, you'll see these big time stepped values every time the function chose 10. And same thing if I went -10. So you see these big steps downward in this case. And so that's the idea. And so what we do in simulation of discrete stochastic processes is we randomly choose these reactions to occur randomly, but they're most of the time based on some probabilities based on your design. But that's the basic idea. Anyway, I hope this helped you understand random walks with discrete stochastic processes, and I will see you in the next video.